Mean, median, and mode comparisons here. It says adults who are being tested for dementia are asked to perform mental tasks such as listing as many animals as they can in 1 minute. Here are the number of animals listed in 1 minute by 24 normal, non-dementiated adults. Man, 1, 3, 3, 5, there, you put them in order for you. And in fact, they gave you a table too. Not that that makes a whole lot of difference either way. It says, which measures of central tendency do not exist for this set of data? If I have this set of data, can I find the mean? Can I find the mean? It's not telling us to find the mean, can I? Yes, I can. Can I find the median? Can I find the middle number? Yes. Can I find the mode? Can I figure out which number occurs most? So, which ones do not exist? None of them. I can find all of those things, right? If I have my list of data, I can find the mean, the median, and the mode. Suppose that the measurement 19, the largest of the measurements, was replaced. I'm going to get rid of this one and I'm going to put 39 in its spot. Which measures of central tendency would be affected by that change? Would that change my mean? Yes, it would, because I have a bigger number there. My mean's going to be higher. Would it change the median? No, it wouldn't change what the middle number was, right? So the median would be the same. Would it change the mode? Would it change which number occurred the most? No, because it wasn't the 19. So the only one that it really affected was the mean. The mean would be higher. I got to move my board. Suppose that starting with the original data set, the largest measurement was removed. So we take the 19 off altogether. Which measures of central tendency would be changed from the original data? So if I took the number 19 off the list of my data, would that change the mean? Yes, because I have one less number, it's going to be smaller, right? So the mean is going to be smaller. Would it change which number was the median number? Would it change which one's in the middle? Yes, it would, because now I have a shorter list, right? Unless I happen to have the exact same number in the middle and it didn't affect it, but it would change the median. Would it change which one occurred the most? No. Still have the same one that occurred the most because the 19 wasn't the one that occurred the most. Part D, which of the following best describes the distribution of the original data? Choose only one. I want to go back up to that little graph they have up there for me. If that would let me do that. Close the ink. I didn't want to open that. There. Okay. So, in this case, when they're talking about the skew, if I look at this data, does that make weird noise? If I look at this data, it looks like it's pretty evenly matched, right? It's not going towards one end or the other. So on this one, it's roughly symmetrical. It says our choices are negatively skewed, it's going towards the negative side, positively skewed, or roughly symmetrical. That list of data is roughly symmetrical. That's why they have the picture there. Why does it keep wanting to save instead of close? All right. Let's look at number 17 there. Number 17, it says, for these data, which measures of central tendency take more than one value? Are you going to have more than one mean? No, I'm only going to find one mean. When I find the mean, I just have one number. Am I going to have more than one median? No. There's only going to be one number that's in the middle. Am I going to have more than one mode? Yes. Now I would have to look at my list of data, but if I look at my list of data, which numbers occur the most? I've got 3 of those and 3 of those. I've got 2 numbers in my mode. So there, if I look, the mode has more than 1. Suppose that the measurement, 123, which is my largest measurement, was replaced with 154 instead. Which measures of central tendency would be affected by the change? So which would that affect?
Mean.
That affects the mean. The mean would be higher since I made that last number higher. The middle number should still be the same. The mode still should be the same. I still have the same 2 numbers. You do have to watch the median sometimes if it's something that might be effective, but in this case it's not. Part C, suppose that starting with the original data set, the smallest measurement was removed. So this time we're going to leave the 123, but we're going to get rid of the 26. What did that change? The mean again. Change the mean. The median, the mode should be the same. Whoops, that's why they did that. Well, how did that get checked? Let's see if I can get rid of it. All right, part D, whoops. It just wants to pop up with weird things today, I guess. Part D wants us to describe which of distribution is my original data. Whoops, there's my distribution there. So, if I have my data like that, they're going to call that smaller end the tail. Whichever way the tail goes off, that's either your positive or negative. This is going to be positively skewed because my tail goes off in the positive direction. If it would go off the other way, then it's going to be negative skewed because it'd go in the negative direction. So this one is positively skewed because it falls off towards the positive direction. And number 18 here. A survey of 22 retirees was taken. Among other things, the retirees were asked to report the age at which they retired. Here are those ages. And again, the first question says, which measures of central tendencies do not exist? My answer is going to be none. We have a mean, we have a median, we have a mode. We can do all of those, so none do not exist. Suppose that the measurement 79, which is the largest one, was replaced by 84. Which measures of central tendency would be affected by the change? The mean. Suppose that starting with the original data set, the smallest measurement were removed. I got rid of it altogether instead of changing it. Which measures of central tendency are going to be? The mean. Again, you might want to check just to see if your median changed at all, because sometimes if I remove something, that might change. But in this case, my median's not going to change because I had all these 64s in the middle. So if I move over one number, I'm still going to be at 64. But the median could change by removing a number. You want to double check that. Which number's still in the middle? In this case, 64 is going to be in the middle either way. So watch for that one. And what does that last question say? Must just be a little bit off of where I think it's supposed to be. The relative values of the mean and the median for the original data set are typical of data that have a significant skew to the left. What are the relative values of the mean and the median for the original data set? Choose only one. So, if I'm looking at this and it's skewed towards the left, which means, again, that the tail goes off to the left? Is your mean going to be greater, your median greater, or you can't determine? Greater than, I gotta read that again. The relative values of the mean and the median for the original data set are typical of data that have a skew to the left. What are the relative values of the mean and the median for the original data set? I know I looked in the book and the book had a big chart. I remember that. The median is what ends up being greater. I'm pretty sure in the book there's a table that says if it's skewed to the left, the mean or the median's greater. If it's skewed to the right, the mean will be greater. Da 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 da. And I'm pretty sure that's what I did as I looked it up in the book. I'll have to read that again to figure out what it was talking about. All right, that's one homework page there. All right, let's work till about 4 o'clock, unless you want to go early. How long a break do you want? I'll leave it up to you guys. How long a break do you want before we do our second?